after you made rectangles with either your base 10 unit cubes or some Cheerios, any sort of manipulative will work. I hope you noticed that, and I hope you didn't forget about the long skinny rectangle, right? That we could make that would be a dimension 1 by 24. All right, and then as you continue to make rectangles, I hope you noticed as you moved down the list and you made these 4 rectangles, by the time we get to 4 and 6, we get a more square-like rectangle. We don't get a perfect square because 24 does not make a perfect square. It's not a perfect square kind of number. Anyway, if we were to make a perfect square for 24, we could approximate that. Okay, and if I were to take the square root of 24, and the square root of 24, when I do that on my calculator, I get, it's close to 5, right? I would expect that, 4.89. Okay, so if I made a perfect square, make a little bigger. Oh, I haven't mastered this tool yet. I'm trying to make it a little bigger. Well, imagine it's a little bigger. And each side here would be 4.89. But one of the things that I'm going to be asking you to do is to compare the square root to the numbers in the list. Okay, so if this was the perfect square, as I worked my way down this list, the rectangles become longer and skinnier. Okay, so if this is a perfect square, to make it longer and skinnier, one side gets smaller, one side gets larger, right? Then I make this other side even smaller, this other side has to get even larger, and so on, down to the point where I'm at this extreme, the really, really long, skinny case. So anyway, what we have found here then when we've made these lists, we've actually found factors, right? The factors of a number. So I'm going to give a very elementary school level definition of factor, and then we'll step our way up into a more college-like definition. But let's say that the factor are the dimensions of the rectangles that I can make. Okay, that's an elementary school definition of factor. All right, a more college level definition of factor then would be that a factor of a number divides the number without leaving a remainder. Okay, that's a better definition at our level. Okay, so anyway, if I wanted you to find, say, the factors of 36. Okay, so here's 36 over here, and I wanted you to write all of the factors out. Notice over here, I went in order. All right, I said, okay, one always goes in. One in the numbers, always a possibility, right? Then I say, okay, does 2 go in? Right? Does 2 go in? Does 3 go in? Does 4 go in? 5 go in? 6 go in? And so on. And then as soon as I start to repeat, I'm done. Or another thing that you might notice is as soon as I pass the square root, I'm done. That's the point where the factors will start to repeat. Okay, so if I make a perfect square, I have nowhere else to go besides back the other direction, right? So if I made the 4 and 6, if I made a perfect square, then my next rectangle would have to be 6 and 4, right? Dimensions 6 and 4. So therefore, I know I found all the factors. So as soon as I get to the square root, I know that I'm done. All right, so you take a minute and list all the factors of 36. And as soon as I repeat, I know I'm done. All right, so all of these are factors of 36. All of these numbers divide 36 without leaving a remainder. Now, one of the things that I'm going to ask you to do in a couple more of these examples is to determine what you notice about the numbers in this side of the list on the left-hand side compared to what you notice about the numbers on the right-hand side. Okay, so you could say things like, well, all these numbers are less than blank, but all these numbers are greater than or equal to blank. Okay, so same idea applies over here. This side, what do we notice about these numbers compared to these numbers on the left? So one thing that I want you to notice about factors is that factors come in partners. I don't know if you can hear the noise in the background. Craig, I'm recording. It's just started absolutely downpouring outside. That might be evident on my video. The sky just opened up and the rain just poured down, so you might be able to hear that. But anyway, all factors, or let me say this, each factor has a partner, right? And I know that because factors are dimensions of the rectangles. How could I have a dimension, a length, without also having a width? Okay, so when I say each partner has a factor, that's what I'm referring to. So let's do one more activity. Let's look at all the factors of 108 and 65. All right, so some of the numbers I'm looking at have lots of factors, like 108 is going to have lots of factors. And then let's look at the factors of 65. But another thing that I want to do is point out the square root of 108 and 65, because again, we're comparing the numbers on the left with the numbers on the right of my list. Okay, so square root of 65, and there's a reason why I'm doing this. This is going to lead me into an important rule that's going to help us do something a little bit later on. Okay, so square root of 65 is, actually, I don't know. You guys start listing these factors and I'll get out my calculator and find the square root of 65. So 65 has very few, right? 108 has a lot of factors. Again, I went in order. Does 1 go in? Does 2? Does 3? Does 4? Okay, 5 doesn't, 6 does, 7 doesn't, 8 doesn't, 9 does, right? And notice I said as soon as I pass the square root, I know I'm done. Or, you know, if I kept going, does 10 go in? Does 11 go in? No, they don't. Does 12? Yes, 12 does, but I've already got it. So as soon as I start to repeat, I'm done. So I hope you would notice, this is why I wish we were in class, because I would ask you right now, and someone would raise their hand and tell me that they noticed that every number on the left-hand side is less than or equal to the square root, whereas every number on the right-hand side is greater than or equal to the square root. All right, so that's going to be very useful to me a little bit later on. And this information will help me when it comes to finding all the factors and knowing that I haven't skipped over anything. So let's say this. Let's make this generalization that when finding factors of n, all numbers in the left list, maybe I'll say left side of the list will be less than or equal to, let me see, oh, do I have math symbols up here? I haven't played with this enough. I'll just have to type it out. You guys can use the symbols. Less than or equal to square root n, and all numbers on the right side are greater than or equal to the square root of n.